In this video, we are going to learn how to draw Lewis structures of covalent compounds and how to draw Lewis structures of some polyatomic ions as well. For example, let's start with the covalent compound carbon dioxide, CO2. And then we will look at polyatomic ion sulfite, which is SO3 2 minus. So carbon dioxide, first and foremost, step one is to count the total valence electrons in a given compound or an ion. So for carbon dioxide, CO2, carbon has 4 valence electrons. Now, where am I getting this from? This was discussed much earlier about in a video on electron configurations. When you draw the electron configuration diagram for carbon, you have 1s2, 2s2, 2p2, and the last shell is the second shell, the 2s2 and the 2p2 shell. And when we say 2s2, the last two we say here, 2s2 and 2p2, these are the electrons which show up here. Right, so with that said, we will not talk about how to count the valence electrons beyond what I mentioned here, but please look into electron configurations if you have forgotten how to count the valence electrons. Here we have 2 oxygens, each one has 6 valence electrons. So we end up with a total of 16 valence electrons. Carbon dioxide has 16 valence electrons. Now, step 1 is to put that atom which occurs only once in the structure right in the center and the other 2 symmetrically around it. Like that. Right, now usually the one that occurs only once also is the one which is the least electronegative, but most of the time it's going to be the one that's happening only once. So that way also you can remember to put it in the center. Now within this step, I would say after counting the valence electrons, step 2 where we put them in this order, symmetrical order, also put single bond between the central atom and each side atom, and each bond corresponds to 2 valence electrons being used. So right now we have used 4 valence electrons. Step 3 is to give an octet to each of the side atoms. Octet means 8. Every atom bonds because they want 8 valence electrons, whether it's ionic bonding or covalent bonding. So oxygen, let's start with this oxygen. Currently we can say that it has these 2 electrons. They belong equally in this bond to this oxygen as well as this carbon. As we look at this oxygen, let's say it has 2, which means it needs 6 more electrons. So we put them in as dots now, but they must be paired together the way I'm doing. Right, so we put 6 dots representing those 6 electrons, and this 2 here added to those 6 makes it 8. And keep count, we had used up already 4 electrons, now we use 6 more, so we have used 10 electrons. And now go to the other side atom, the other oxygen, and also give it a valence of 8 by giving it 6 more electrons. All right, so we have used up all the electrons. Both of the side atoms have an octet. The central atom, the carbon, does not have an octet. So what should we do? Step 4 is to give an octet with any remaining electrons to the central atom. But we ran out of electrons. We used all the 16. Then what do? Then we go to step 5, the last step. In that step, what we do is we simply take a pair of electrons from one of the side atoms or both side atoms and use those pairs to make double or triple bonds with the central atom. So if I was to take a pair, let's say I took a pair from here and use that pair here. Now, did this oxygen not maintain its octet. Let's see, 1 2 3 4 5 6 7 8. It's a double bond, and there are 4 electrons altogether in this bond, and there are 8 electrons for this oxygen. But now this carbon is closer to getting an octet. It has now 4 plus 2 6 electrons, and to keep it symmetrical, we will take 2 more electrons from this side and this side and put it onto the center, a double bond, and now we have the structure completely done. Right. This is the Lewis structure of carbon dioxide. Applying the same rules to sulfite. Sulfur has 6 valence electrons. Oxygen has 6 as well, but one more thing to take into account is this 2 extra electrons to add, and so it becomes 26 electrons, right? Here sulfur is in the center, the oxygens, 3 of them on the side. Make a single bond between the central atom and each of the side atoms, keeping track of the electrons. So we use 6 electrons. Now let's give an octet to each of the side atoms in pairs of electrons. That's 6 more. 6 more. So 18 are being used so far. And 2 more. I mean 6 more. So 6, 6, that's 18 plus 6 in the bond, that's 24. All the side atoms have an octet. Step 3 done. Step 4, give an octet to the central atom with remaining electrons. 2 electrons remain because we have 24 used up, but 26 were available. So I put those 2 here, and now my central sulfur also has an octet. And we don't need to get to step 5 because step 5 only gets called when the central atom does not have an octet and we ran out of electrons. That's when we make double or triple bonds. So this is how we make Lewis structures.